Hi, everyone. Happy November. Welcome to another meetup of the Mid-Cities Clojure meetup group. My name is Daniel Craig. If you haven't been with us in person before COVID started, you probably wouldn't recognize my face, but I've been just attending, and this time I'm pleased to be presenting, and so I welcome you all here. Thanks for joining us. If you're here, I'll assume that you love Clojure, or you love music, you love music software, or you're a friend of our presenter, Bobby. So welcome, and I hope you all are able to feel free to ask your questions that you have and learn something tonight. So we're here for Clojure Talk. We're here for supporting your interests and for helping you to make Clojure a part of your life in a way that's brings some fulfillment. So just feel free with your questions to ask anything, be it advanced or beginner level question, just fire away. So for tonight, we've got a really cool speaker teed up. So his name is Bobby Tables. So we're actually still awaiting his arrival, but in the meanwhile, I've got a quick little lightning presentation that I'll make of something that I've been working on this week. It's something that really excites me. It's a physics simulation, but only in the kindest terms would you really term it a simulation. But I'll jump into that in just a moment. So I first wanted to say to everyone who's new or who's joining us for the first time or who hasn't taken that step yet, I hope you'll join us on Slack. It's the Mid-Cities Meetup Slack channel. That's mid-cities-meetup kebab cased. And there you'll find us, during the month when we're not meeting up. We meet the first Monday of every month, but between meetings, you can find us there. And we'd love to have more chatter on the channel. So look forward to seeing you there. And as I say, if you have any questions, just throw them in the chat or in the Slack channel, but I'm actually not looking at that right now. So I'll go ahead and transition into showing you what I've been working on. So, so what I wanted to say before I start telling you about it is that this is something that I've done for mostly for a use case that my dad presented. My dad's a physics professor. He teaches at a community college, and when Flash died and when Java applets became kind of problematic, a lot of his preferred teaching tools started to disappear, started to become unsupported, all that sort of thing. But I'd heard that Clojurescript really fills the void that Flash left, which really kind of had me intrigued because I wanted to know how could I make these interactive things like I'd seen in Flash that I didn't see anymore. So I'd like to report that happily Clojurescript was quite easy to use for this. I've made like a little simulation of a projectile. Imagine that a projectile started from here and launched. In the absence of air, if this were flying in a vacuum, this is the path it would follow. So, you can move its initial position, initial velocity. But the important thing is that I'll just quickly walk through how I did this, and hopefully it'll be kind of a nice intro to the world of Reagent, of Reframe, and of a little bit of an intro into physics programming, although I don't claim that this is anywhere near state of the art or how people would do it who actually are physics programmers. So I'll just go ahead and say that what I did first was I went to my physics textbook from college and I just grabbed a screenshot, or not a screenshot, but a photo of the equations that represent the change in position and the change in velocity. So S represents position and V represents velocity. And so this represents the final position in the X dimension, and this is the final position in the Y dimension. And similarly, the final velocity in the X dimension and the final velocity in the Y dimension. So these definitions, this is dt or delta t. This is the step in time, the time interval that's going to occur between every frame, so to speak. And this is G, the gravity constant. So these guys, without diving into them too much, because frankly, I think they read more easily when you consult them in a math textbook or in a physics textbook. They represent how the different components of state of a projectile change over time. So of course, if you're modeling a projectile in a two-dimensional plane, you'll have the x dimension and the y, and then the velocity in the x dimension and the velocity in the y. So each of those changes from step to step, and so with the simple function definition, I was able to make those guys basically independent definitions that just are reusable and nice. So I'll move on, kind of leaving those a little vague because I think that they basically, like, if you dig into them, you'll see that they're just as simple as the definitions that you would look up on, like, in a physics textbook. So it's kind of outside the scope of what I want to address, is particularly for time reasons, to dive into the physics of it. But this was my next thing that I did, and it was my first time using loop recur. So this is a structure in Clojure that, from every source that I saw, it kind of overcomes the limit of recursion on the Java virtual machine, as well as Enclosure because there's no tail call optimization. There's this construct, this special form called recur, where if I declare a loop and I declare these initial bindings for the loop, so these guys, this is my initial position, this is my initial velocity. If I then bind those to S and V, which represent position and velocity, and then I say that my next recurrence is going to be represented by the vector of the final position of X with the S and V as they stand now, the position and velocity, and the final position of Y as they stand now. And then same for velocity, the final velocity of X and the final velocity in the Y dimension, knowing that the position and velocity going into this step, then recurring back gets me the next iteration of it. So in a sense, like this guy, this vector that I've defined here becomes the next SI. Oops. This is the SI that I'm referring to. So, but really it gets plugged in right here in S. So really it's more truthful to say that it becomes the next S, the next position. And then this vector represents the velocity. This is the velocity in the X, and this is the velocity in the Y. So it becomes the next velocity in the next step. And this is the result. The result is sort of a way of aggregating all of the states as the projectile travels. So I just conjoin the new position and velocity as a vector to the result. And then at the end of it all, I just return the result. So as a simple demonstration, if I was to show you how the sim trajectory works, then I could just do a quick definition and say that I want to let SI be 0, 0, and I'll say that VI, the initial velocity, we'll say that it's 30 in the X direction and 20 in the Y direction. So then if I want to sim the trajectory of this guy, then I can just simply call sim trajectory with the initial state and have what I need. So moving on. So this is the part that has more to do with Reagent. So Reagent is a wrapper around React. So React, as you know, is a JavaScript library that comes out of Facebook, and it has to do with modeling pages as a pure function of data. So data comes in, the React page defines how it's transformed into essentially into a page. So this is a React component. This is a projectile view component. And it's what you see here in the box. Essentially, this invisible box that has this curve inside of it is the projectile view component. So the first thing that I've done is subscribe to this piece of state that's held by the app database. So that's a way of centralizing all your state into one central place. It's part of the philosophy of Reframe, which is the Clojurescript single page application framework that's most popular in my observation. I'm not sure if that's actually truthful, but from what I've seen, it's the most popular. So it has a philosophy of, just like React, you know, your page should be a pure function of data, and when the data comes in, it gets transformed into a page in a way that's like consistent and reproducible and that is efficient. So essentially, I just subscribe to this piece of state that's in the database. That initial state is actually in this simple single page application, it's the only piece of state that's held by the database. So then I've gone and bound the name trajectory to the result of this function sim trajectory that I tried to demo a moment ago. So that's a vector of vectors that represent positions and velocities at different points in time. And then, so this is a list of positions. I just wrote a little list comprehension to pull out the first vector of each vector. And then this is the one that pulls out the second vector of each vector. So this is the list of velocities. And this is my favorite part of the whole thing. With Reagent, you can simply make an inline SVG. And then with the power of Clojurescript, you can just fill it in. So like, for example, a little side project at work that I'm doing is to make a whiteboard app. You can scribble on it and everything. With SVG, it was seriously easy. And there's a great link on that that I can put in the comments. I really had a fun time learning how to do this. So then to go on and probably to conclude, another philosophy of Reframe is that everything is governed by events. So events are what changes the state of your app. So I've defined this battery of buttons, and each of them has an on-click handler that dispatches an event to Reframe's queue. And these events are defined in another namespace that's called events. So for each of them, I've just defined that, for example, to decrement the initial velocity in the X dimension, what I really want you to do is to update the database. And I want to update the first, the second of the first, the first of the second, actually. It gets a little bit complicated. I need to break that out into like a more nuanced definition, but it, you know, getting down to brass tacks, that's like navigating through the structure of vectors, and I just want to decrement it. So if I push the button that corresponds to the velocity in the X direction, then that item in the app database is going to be decremented, and that's how you'll see that the path of the projectile changes. And then to round it all out, this is the definition of the main panel. This gets injected into the page, and it gets injected, in this case, as the only thing on the page. And you can see that I just put my projectile view and then my control view. So that's what these two are. the position moves a little bit slowly, but the velocity moves more quickly. And so you can see that with just a little bit of physics knowledge, this is 74 lines, for example. Now that's leaving out all the other namespaces that Reframe provides when you use the line new Reframe template. But with just simple definitions, you can have something that really like models the real world. So I found it to be a pretty exciting application of my physics knowledge that I always knew was a topic that people talked about in programming. I always knew there was such a thing as physics programming, but I'd never gotten to put my fingers on it. And it also brought in this new interactive stuff that I've been learning with Reframe. So between the two of them, it was a pretty happy union, and I'm pretty pleased with the way it turned out, although it's quite simple. So maybe I'll take a glance at the comments and see if there's any questions.
Well, yeah, I can actually help you out with one of the questions if you want to go back to it real quick. Sure. So Proctor has asked, why was loop recur picked over a map reduce style, possibly even reductions?
So I actually, I tangled with this for a little bit because I've been listening to the Functional Design Enclosure podcast, and the reductions function is what I wanted to use because it gave me that list of future states that I wanted, but I just couldn't make it jive in my mind. Like I didn't know how to. I guess I'm just a little too green still with reductions and with reduce, and I didn't know what I'm really reducing. Like, would I be reducing a list of increments of delta t, or it just didn't really fit in my head. So I did it the way that I think was probably a little bit more like traditional imperative programming. Probably the loop recur is like a little bit more familiar for me, but I wanted to make it work the other way, and I didn't figure it out.
Awesome. Yeah. There are no other questions at the moment.
Okay.
All right.
Great. So this is what I had to share, and this is, if you want to try it out for what it's worth, I put it at my URL that I got, danielmartincraig.net. So it's not extravagant, but it's oh, well, actually, it's worth talking about actually, because this is all a static Clojurescript compiled project. If you want to see how it's done, you can just simply do this step. So it talks all about it when you do. So this is what I was talking about. If you want to create a new Reframe app, you can use the Reframe template, and then you should check it out because there's, in the documentation, it talks about how you can use this thing called 10x that helps you browse the internal app database. And then I also do plus cider because that helps it
slightly bigger.
Yeah, totally. Let's see. I always forget about that, and I have to apologize. Preferences. Cell spacing, cursor shape, cursor blinking. Maybe it doesn't change until I make a new terminal or close it or something. Well, do you know how to do it, John? Zoom in. Oh, there we go.
Right there. Yep.
Good. Okay, so if you take advantage of this Reframe template, it's available through Line Again, and you can read about it on GitHub. It'll set up all your app for you, so it's pretty cool. And then once you've done that, you'll see that in the README file, it has a description of all the things you can do. So like, it looks pretty ugly because this is Markdown. and it should be seen in a Markdown browser. But essentially what I want to point out is that it's got all the setup and all the DevTools info and everything, and the CIDR info too if you want to use Emacs. But if you want to use Calva, it's also works well with that. So what I want to point out is that if you do this command line release, that comes predefined with the template to help you to compile all your things into simple compiled JavaScript files. So if I show you the resources folder inside the public subdirectory, you're going to see that it has index.html and JS. So like to show you, look at this. So if I show you this is what I was talking about, where like this is the div where your app gets injected into. So this div called app, the JavaScript browses the structure of your page and finds that div and injects the app into it. All your Clojurescript code that gets compiled into JavaScript just gets jammed in right there inside that div. So to show you, this JS folder has all this compiled JavaScript stuff, and there's no backends to any of this. So this is all totally just purely front end. You could do the backend too, and actually the template has provisions for that. But this is my page that I've just done on Amazon S3. So it's inside an S3 bucket. The S3 bucket is configured to host a static web page. And I bought the domain name through Amazon as well. And then Amazon has tutorials on how to set up a static web page hosting. And then essentially from there, what you need to do is just make sure that your domain name servers are the same as those that are given in the configuration for the bucket. And then I don't know, just follow the tutorial, but I think that's all the steps. And it was a pretty fun project. So while this isn't the final state of what I want for my web page, it's pretty cool because anybody could go out and see this danielmartincraig.net and see my little Reframe app. And you know, it makes me feel good knowing that if somebody had to ask, like, so have you done any projects? Like I could show them, like, sure, like I've got this little project, and I could talk about Clojurescript and Reframe, and they could just pull it up on their phone and it'd be just as available as anything. So that's what I got to say about it. It was a pretty fun project.
Awesome. Thanks for sharing. All right. Well, I think we should switch gears for a little bit. So our main speaker for tonight, we have been having difficulty connecting. And so I think what we want to do to move forward is actually do a little bit of pair programming. So I think what would be super fun is if we can pull up some of the Project Euler problems and we can work them together and solve for some of them. And so in order to do that, Daniel, why don't you go ahead and go to projecteuler.net. So that's projecteuler.net. Yeah, and so we're going to take a look at the archives, and we're going to just start at number 1.
Okay, great.
Okay. Now, for those of you that want to follow along, a helpful way to do live programming and figure these type of things out is to use your REPL, right? So that's your read, eval, print loop. And there's actually one that's out there, an add-on to the REPL called Rebel Readline that makes it a better experience for your terminal. So I'm not sure if you're familiar, Daniel, with Rebel Readline. Are you?
I've heard of it.
Sure. Yeah. So so why don't you pull up in the GitHub page? You can just do a quick Google for Rebel Readline, and there's going to be a command in there to start a terminal session with the Rebel Readline. Yeah, it's that first link right there.
Okay, great.
Scroll down just a little bit more. Right there, the quick try. Yeah, so you can take that right there, that command, that whole thing, and if you pop it in your terminal, it's going to load everything that you need to have a Rebel readline session.
Is that big enough, John?
Maybe one more.
Okay.
Yeah, there you go. That's great. Yeah, so go ahead and run that. Excellent. And then also, as a quick note, for those of you that are trying to solve along with us, in the chat, I'll be looking at your submissions. And if you want to participate, feel free to also put in your contributions. I'll bring them up as well. All right, so now you've got a REPL session that's open, right? And so what's cool about this is you get some syntax highlighting. You also get paren matching. So try some things out real quick just to get your bearings, make a function, or yeah, do the things that you want to do, and then we'll switch back over and read the problem. Yeah, one cool thing I like to do is when I am looking for the documentation of a function, you can actually put your cursor over the function name and hit Control-XD, right? Sorry, your not your mouse cursor, but your keyboard, right? So you can hit the up arrow or that. Yeah, you just type it. Put it right at the end of the function name and do hold down Control, hit X, and hit D without lifting up Control. Yeah, there you go.
Wow, okay.
You're pretty cool, right?
Yeah, that's sweet.
Yeah. All right. So with that, why don't we go ahead and read the problem? Can you maybe zoom in just a little bit more in your browser? Yeah, there we go. And let's read it out, and we'll start working the problem.
Sure. So this is problem 1, multiples of 3 and 5. It says, if we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, and 9. The sum of these multiples is 23. Find the sum of all the multiples of 3 or 5 below 1,000.
All right.
3, 6, and 9. Some of these multiples.
Yeah, take some time to digest it, right? And we'll start working the problem.
Find the sum of all the multiples of 3 or 5 below 1,000. Okay.
Yeah. Right. So if we were to break up this problem and look at individual parts, right? If we just took the sum of all the multiples, right, and try to get 23, like how would you express that in a function?
The sum of all the multiples and got 23. So my thinking is that you would have to
so like it says it there in the problem where it says the numbers below 10 that are multiples of 3 or 5, we get the number 3, 5, 6, and 9, right? And so if we sum those together, we can express that in a function with just the open paren and a plus, and then pop in 3, 5, 6, 9.
Okay.
And yeah, and you eval that, you'll get 23.
Great.
There's the example right there. So how would you break this problem apart?
Okay, so I think that my mind is kind of leaning towards some sort of an iterative approach. I know that you can find the multiples of a number by adding it repeatedly. So I I'd imagine that, like most problems like this, there's a better way to do it, but it's never bad to start from what you can, start with. So
Yeah.
I'd say probably you could have some sort of set of call it multiples, right?
Mhm.
And then for all the multiples, you could just, iterate over 3, 6, 9, 12, like iterate over repeated addition of the number 3 and of the number 5, and then add those to the set. And then, once you got to 1,000, you could stop and sum them.
Uh-huh.
One way to do it.
That's definitely one way to do it. Another, maybe perhaps more functional way to do that is if you were to, say, take a range of 1,000 and then filter the range on maybe a function that checks on whether or not it's a multiple of 3 or a multiple of 5, right? And then you apply plus at the end of it.
Okay.
Right? So if you wanted to maybe create a function that checks if it's a multiple of 3 or 5, do you know kind of what you would do to make that type of function?
So I'd imagine, so I'm going to have this function that takes a number n, and I'm going to say that it either needs to be, what is it in Clojure? Is it mod?
Yeah, mod. Mm-hmm.
So mod in, I'm getting ahead of myself, but mod in 3 needs to be equal to 0,
Mm-hmm.
or the same again, but mod in 5 instead. So all that to say that if the modulus 3 is equal to 0, or if the modulo of 5 is equal to 0, then that number is a multiple of either 3 or 5. So
Yep.
just like that, I think you could accomplish the goal with this function.
Yeah.
It didn't definite.
So try it out with a few numbers.
Okay. So let me change this up. I'm going to make a definition of this. Defin test in. Oops. Okay, this is a little new. Okay, so I'm going to say test in, and then I'm going to try it with 5. And so it gives me true. And for 4, it gives me false. So early results suggest that it's working correctly.
Yes.
True again. True. Okay. So I'm pretty confident in my solution at this point.
Awesome. Let's keep going. Let's put it together.
Okay. So now you said that we wanted to take a range of 1,000. So that's a little unfamiliar to me. Is there a range function? I know in Python there's a range.
Yep. Yeah. Try it out. Just do range in 1,000, right? And don't forget, you can do the Control XD on the function name, and that'll do it for you.
Oh, I see. Great.
Yeah.
So now this guy tells me that it's going to return a seq of nums from start to end, including, well, it doesn't include 1,000, but the problem calls for it to be below 1,000. So now I've got this range of 1,000 numbers starting from 0 and ending at 999. So that would be a pretty good one to filter over in the way that you were talking about.
Yep.
So I've used filter before. I've used it to filter out nils.
Yeah.
So filtered lets me define a predicate which returns either true or false. And if it's true, it keeps it. And if it's false, it tosses it. So I'm going to say that my predicate is test in, and my range is 1,000. If I do that, then just as I expected, I see that numbers have been tossed. So I'm seeing gaps between my numbers now. Probably if I was to look through it all, it'd be a much shorter list than previously. But to be short, I can see 3, 5, 6, 9, and those are my ones that I expected to see.
Uh-huh.
Okay, great. So now that I've got that, essentially all I need to do is sum them, right?
That's right.
So you said that I should apply this guy to there. So to look up my doc string again, so apply takes a function and a list of arguments, or I should say a seek of arguments, I guess. And so it essentially treats this as if it was, it kind of, well, I don't know. It's hard to describe what apply does without using the word apply. But this plus is going to be put into effect to sum up everything that's in the sequence here, the second argument to the apply function. So I would expect then that this would solve the problem to sum all the multiples of 3 or 5 below 1,000. So if this is the right answer, then my assumption is correct.
Ding, ding. I mean, that's the answer I got. So yeah, if you're in the chat, let us know if that's the answer that you got. So if you want to, we did have a submission from Alex.
Okay,
so
great.
I'll put that up on the screen. Why don't you try and put that in and see what number you get? Maybe those numbers match. So if you want to just switch back over to the to the tab and grab the
I see from Alex Valdez, I see solution. Let's go back over to the problem and bring my window. Paste this guy. Okay, so I'm seeing reduce plus filter. So yours starts with reduce. Okay, let's see what we can learn from the different approach. So I see reduce plus filter function x or, so that's similar. That's identical. And then range 1,000. Reduce plus. Okay, I'm starting to see the picture here. Yeah, so we get the same result.
All right. So I think you can have a little bit of confidence that that you had something that was working.
Yeah.
All right.
Great. Any other solutions?
Yeah. So here's a question. Do you think that you could rearrange this function using a threading macro? You familiar with those?
Yeah, so a threading macro, yeah, I am actually. So a threading macro is like this guy.
Mm-hmm.
And so if I was to, like say I was to give it some sort of item, then the threading macro would put that as the first argument to the list of functions that I provide. And then successively, each result of each function becomes the first argument to the successive function. So if I understand right, this is what I could do. Or is it just print? And then, yeah, just like that, my name becomes the first argument to the print function. And you could do more advanced things. Like to pick something mathematical, you could do like 1, and then ink, and then, oh no, this would have to be this way. And then declarative. And then, yeah, so you're just putting the result of each function call as the input to the next, almost as if you were just doing this. It would be like taking this guy and turning it into what looks more like sequential code.
Yep. And so are you familiar with the threading macro that has the 2 greater than signs?
So that would put it as the last what do you call it? The last parameter to the function, wouldn't it?
Yeah. What is the it?
What is the it? Just this item. I'm not sure what it's called, to be honest.
Yep.
Yeah. Okay. So
So can you try solving the problem then that we just did, but using the one of the threading macros?
Using a threading macro. Okay. So to start where I started before, I could say that I have a function. Well, let me just define it. And it's going to test my in. And if I'm going to be using a threading macro, then I need it to be able to test my in against my conditions. So let's see how I do this. So my thing would have said otherwise. It would have said equals mod. Oh, maybe this isn't the way I want to do it. I want to do it this way, I think. Because I was going to say threading macro and then equals mod in5, but I think what you're driving at would have me use the or, and then it would say threading macro in, and then I would say mod 5, and then it would say equals 0. And then from there I could define another. Maybe this isn't what you had in mind, but this is another for the 3. And now that I've done that, I've defined an OR that checks the modulo of 5 of the n, whether it's 0 or not, and then of the 3 as well, and then says OR, and then returns the result again, just the same way the original did.
Yeah, so I'm really interested in how this is going to look, because so what I had in mind was just the final composition where you're using this function, right inside of your range and all that. But yeah, I'm interested if the original call that you had. So if you hit up arrow a few more times and go back to your apply plus, form, if it's going to work exactly the same.
Okay, we'll give it a shot then.
Yeah.
Okay, let's see. So I had apply plus.
Well, and so here's another trick. You can hit Control R, type apply, and Control R again. Yeah, Control R, right there.
Wow.
Yeah. Boom. Hey, it still works. Excellent. Nice.
So yeah, there you go. Threading macros. Phew.
Yeah, those threading macros. So just as a real quick, what I had in mind is that you would do a threading macro, do 1,000, pass it to range, right? Pass it to your filter, pass it to apply.
Oh, I see. So threading macro 1,000, range, filter. Oh, but this needs to be. This is why you mentioned this earlier.
Yeah. Yep.
It needs to be that one, and then from there we go filter, test in, and then from there apply plus.
Yes.
Okay, yeah, that looks good. So there we go. Same answer.
Yeah. So in a way, it looks a bit more readable. I guess it's in the eyes of the beholder. Like if it was much hairier of a function, it could possibly be a lot more simpler to understand by using these threading macros.
Yeah.
Yeah. So quick surprise, our speaker did join. So I think I'll let you introduce him, and we'll go a bit long tonight, but it's okay because it'll be in the recording for anyone who can't stay longer. So I'll let you introduce him, and we'll get going.
Okay, great.
Great.
So, welcome to our speaker. You guys have all read the title. The title is MECCA, the Music Education Composition Creation Application. So, we're excited to hear about what that entails. It's an application that brings together ideas from education and music, and personally, I'm really excited to hear about it because my family's musical, but I'm a programmer, so it gives me some common ground if I can talk about music with them. But so to go into the bio that our speaker provided, I'll read that following a 2015 accident that disabled one of his hands, Bobby needed to reinvent both his career and mode of self-expression. As a music student, teacher, and performer suddenly without the ability to use conventional instruments, he saw the tremendous potential of technology to make up for this by providing, as it always did, the tools for blazing and navigating the avenues of creative expression as well as productivity. Clojure has in many ways provided an ideal language for this, and its community is a huge source of encouragement. The amazing body of work these recent giants have built has made it not only possible but incredibly fun to carry out our artistic visions, and this goes for the actual technology itself as well as the surrounding ecosystem of docs, articles, and forums. He is greatly honored to share this experience with the Clojure community. So welcome, Bobby. We're excited to hear what you have to say. And just to learn about the music side of things that's just new to us. So welcome. And as always, everybody just pitch your questions into the chat and we'll just get them to our speaker whenever he decides to take a break. We'll just field more questions. So.
All right, Bobby, take it away.
All right, yeah, I am so excited to be here because, well, I've spoken at conferences before in the past. Can everyone hear me?
Yes, we hear you loud and clear.
Okay, great. Yeah, this is actually the first time that I was actually asked to speak. I submitted this project to both Enclosure, the Indian Clojure Conference, and Clojure North, but they were both rejected because I guess they don't want to have any fun. And but this is actually extremely important to me, and so what I wanted to do was try to convey what can't be done with documentation very easily is the emotional motivation behind it. And it really started when I made this Facebook post where I said the very state of human creativity is in our hands. I know what we've been missing and how we can work together to achieve the next wave of sonic expression. And yeah, it sounds kind of over pretentious, but my hope is that I can, hopefully it'll be a little bit infectious. So I put this talk on GitHub, and it's designed to be kind of a living document that will improve. And I'm just really thankful to have this opportunity to try this out. This was a rejected title for today's talk, how a music program is going to save the world. And it's because the goal is to fill a gap in our musical culture that I think has developed as a result of certain sociological phenomena, which affects aspects of life besides music. And so I hope that by trying to figure out how we can fix this in the music space, we can develop strategies and mechanisms that can apply it elsewhere. It also could have been called, "Why Does All of Today's Music Suck?" and what we're going to do about it. This was rejected because it's slightly offensive and kind of narrow. I just heard somebody say yesterday that all of the good music in the world was made when I was 14. And it's kind of how every generation inevitably tends to hold the works of their era to a higher esteem and kind of develop a disdain for the crap that's out there today. But I think that it could very well be that there was a time, perhaps deep in our evolutionary history, when music played a much bigger part in our daily lives and also in the lives of more people, particularly the common people, that it might have had, more to do with the way we structure our lives and communicate with each other, and rather than the auditory cheesecake, as Steven Pinker calls it, that music was something that evolved kind of incidentally, as we created our communication faculties and other faculties. Just like we developed a craving for fat and sugar and created cheesecake. And in this book, This Is Your Brain on Music, I read this about 10 years ago, and he dives right into that and presents kind of a theory of human evolution that kind of you could look at it as kind of a brutal takedown of the auditory cheesecake theory. And so I wanted to figure out, why did this happen? And there was this great paper by John Philip Sousa in 1906 called The Menace of Mechanical Music. And he said this was when the phonograph was invented. And he said this is going to be the death of all music, because the child will become indifferent to practice when music can be heard in the homes without the labor of study and close application, and without the slow process of acquiring a technique. It will be simply a question of time when the amateur disappears entirely, and with him a host of vocal and instrumental teachers who will be without field or calling. And I think the whole idea of recorded music, it created a force that operates in multiple directions, where beginners are not encouraged to explore because we've set unrealistic standards. Because of the oversaturation in the media, it's so much easier to just put a record on, because I think the urge to play music is something that we require, that used to be fulfilled by learning to play music, and that's no longer necessary. And I think this is not unique to music. It's another example that I thought of is beauty standards, with we've heard called the Photoshop effect, causing people to have poor body image, and all of social media. In fact, we look on Facebook and Instagram, and we have the false impression that everyone's having more fun than us. And all the professionals lose their sense of exploration because the tools become no longer conducive for the process of discovery. And so kind of the tradition of looking up words in the dictionary for a talk, and I thought the kind of theme is exploration, which dictionary.com says is to traverse or range over a region, area, etc., for the purpose of discovery. And the thing that sticks out to me is that exploration is hands-on. It's you're directly operating upon the thing rather than, you don't explore with a map. You explore the territory itself, not some fabricated representation of it, which I think is what we do with the REPL. We, as Clojure programmers, we're interacting with a live program. We don't just have our source code, which would then compile and run, change it, compile it and run it again, and so on. So I think that we're already kind of halfway there, in the philosophy anyway. So for educational tools for learning music, we have what are I would call music theory trainers. This one here is it's called Tenuto. It's I think for the iPad, and it teaches you music. Here's a circle of fifths. You learn the key signatures, scales, chords, principles of harmony. But what we're talking about is education through exploration. In other words, learning by doing. From my experience being a music educator, and I still love teaching music, and the biggest thing that I've learned is that the best sessions seem to be when the student doesn't even realize that it's a lesson. And so my idea is to integrate these things into something that someone would actually use to make music rather than learn about music. Then, for the composition of music, we have, things like score writers like Finale and Sibelius, that where you're actually writing sheet music. And then we have digital audio workstations, like this one is Logic Pro, which I used to use, which represents music as a piano roll grid. And this one is FL Studio, which when I was in college, my roommate used this one, and we got together and we actually started doing dubstep production. But I had a Mac, he had Windows, and these programs weren't compatible. So we decided to compromise with Ableton Live. This is actually running on my computer here, and I wanted to kind of show this a little bit. Oh, let's see. It looks like, oh, you can't hear that, can you?
It's real faint, but we can kind of hear it.
Yeah, it's just coming through. Yeah, I have to adjust my settings to get that to output, I guess. Well, the reason why I wanted to show this is because it's this REPL idea again. Besides providing a program that was cross-platform, so that we could both use it and collaborate together. This was also, remarkable in a really special way, is that it unified composition with performance. The music is playing in a loop, and just like the REPL again, it is you're interacting with the song as it's playing, and so the whole thing could be done in the context of performance. So that's really that's the idea that I was going for, is that it bridged the gap in the processes involved in creation. Let's see, I need to get back to my... So let's see. I feel like I feel like maybe seeing if anyone has any questions. To be honest, I'm feeling kind of flustered and not sure if I'm really connecting. How's everybody doing?
No questions yet, but I'm learning a lot.
All right, cool. Yeah, I guess I'm just nervous, and the whole all messing the time up thing, it kind of got me. But if everyone's doing okay, I'll continue.
Yeah, I think you're doing great.
So this is a program called Milky Tracker, which is from the paradigm of creating music for video games. And the reason why I wanted to use chiptune music is because it teaches you about how sound waves fit together and how to make instruments, or if you want to consider them instruments, out of just raw sound waves, like white noise, to make snare drums and hi-hats and stuff. And so I asked myself a question, how do I make a note from the command line? That's how this all started. And so I found this thing, the SOX, which it's a command line tool that it was originally designed to convert audio formats, kind of like it's like the FFmpeg of audio. And over the years, they gave more features to it, and so a lot of people don't even realize that it can generate sound waves. And so I made a little wrapper for it, which I wanted to show you here. I have I couldn't figure out how to get it to work in Windows, so I have a little VM here. So yeah, we're in Linux now. So this is just a bash script that I don't know if it's even smart enough to be considered a wrapper, but make a tongue, and it's this little interactive synth. There's a menu here where you pick the note length you want. We could enter eighth notes. And then that would be our bass line. And then we would put to record a lead. And then here it kind of piles it. It puts it with a little drum sequence. This thing actually somehow made it to the front page of the programming subreddit, and someone even wrote an article. Socks synthesizer bash script knocks your socks off, or something like that. And then I actually presented this at a Clojure meetup at Amparity at the Seizure, the Seattle Clojure meetup. And well, the big question was, what does this have to do with Clojure? And so then last year, we were blessed with Babeka, and I thought it'd be fun to do this in Clojure. And so this never been actually demonstrated to anyone, but let me see where I've got that here. First of all, there's something that I really need to fix here. This is completely unacceptable. There we go. Much better. So this is a project that I call Chip Socks, and it uses Babashka, but before Babashka had an nREPL server was when I made this, and so it just uses. I'm just using the socket REPL, and let's see. I think this one's available. And then we'll do that in its own process. Cool. And then I'm not normally a Vim user, but I'm doing this just for this presentation because it runs in the terminal. And so this is Vim iced, I think. So I issue this iced connect REPL. Okay, there's a. So what we just heard was what's known as triangle kicks.
So we're actually not hearing what's maybe what you're hearing in terms of output. It's not coming through the stream.
Oh, really? The let's see. So if I go to oh, actually, I know how I can fix that. Actually, I'm wearing headphones because I didn't want to have any feedback issues. But since generally I'm the only one talking, I think we should probably be fine. If I switch, then let's see. Okay, so let's see if this will play now. So here, what I have here is there's a duration function which just calculates the how long the note is for whatever tempo. So it takes a note value like one is a whole note, 2 is a half note, and tempo in beats per minute, and it computes that. So a 16th note at 120 beats per minute is that long. And then this is the function that calculates the frequency in hertz using this formula, so that we can use numbers which go from 0 to 127. It's an abstraction over the frequencies because our sense of hearing is actually logarithmic, both in terms of pitch and volume. And so this middle C is 60, and so that calculates. So if we wanted the frequency of middle C, I would evaluate this, and it's like 261. And this calls Fox to make a blank wave file. And then here's the function that actually creates the notes. And it takes, it can make sine waves, square, triangle, sawtooth, trapezium. I don't even know what that is. Exponential, maybe, and various kinds of noise. And pluck is like a weird, I think it's actually a guitar string. And it takes a pitch, a note value, tempo in beats per minute, and an optional decay if you want the note to have fade on the end, like in the case of snare drums. Like right here, yeah, this is a snare drum here. Let's see if the audio plays. Let's see, it didn't. It's not evaluating for some reason. Oh, there it is.
Much better.
Oh, that's weird. Oh, you're hearing it because it's going through my speaker and back into the mic. That's interesting. So yes, the snare drum is it's at 60 hertz. Well, the note is at middle C, even though with noise, we're creating white noise, which is across all frequencies. So the note's actually irrelevant, but it's a 16th note with a decay of 0.2. And that's what's creating that sound. And, you know, it's a halfway convincing snare drum. And then these are functions that actually stitch the notes together. And this one will mix them, and then it uses socks to play it. This is the function that actually builds the track, where you give it a sequence of notes. And so so we have all of the building blocks to create a pattern, which would be something like this. Oh, yeah, I need to, I deleted one of my parentheses. Oh, something's not.
You're missing a double.
Oh, I'm missing another one?
Right, it says drums 8I.
Oh, yeah, what is that? Let's see.
Yeah, right after. Yeah.
Oh, yeah, that's the. I'm obviously not a Vim user. It still didn't work.
Yeah, double quote right after the 8.
Oh, thanks. You're so helpful. No. Let's see. These are the triangle kicks that played before. Oh, yeah, no, nothing is. Nothing's evaluating now. I don't know why.
You might have to get rid of that extra close paren that you added right after the play.
Oh, that's not supposed to be there. Oh, yeah, indeed. No, it still didn't. I think I take my word for it that it used to work. Let's see. How do you exit Vim? No, I'm just kidding. Let's see what happens if I try connecting again. Oh, there we go. So it should play the. So yeah, what that is doing is it's creating the illusion of a kick drum out of just bass notes that are actually 64th notes. These are actually the notes. There's 64th notes rapidly descending. So I didn't know how to do this. I took the output of one of my favorite Nintendo games and recorded it, and this is what that sounds like slowed way down. So each one of those, what sounds like a drum, is actually doo 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 doo. Oops. All right, so yeah, this was all the early experimentation with just creating something that would make sound, and that slowly led to this Mario sequencer, which is what I wanted to explain, which meant that I needed to learn some front end development, which this is kind of where I was at. I had made a little Sudoku game in Reagent, and things like Minesweeper, which this actually doesn't. I made this for World Emoji Day, and since it uses entirely emojis, because I didn't even know how to make graphics. I was able to repurpose that. I did this for a job interview because they asked me to implement Conway's Game of Life. Oh, John Conway, rest in peace. And the shocking thing that I realized is that Minesweeper and Conway's Game of Life use the same function, which it's all about that -1 + 1, which is just it led me to this mini revelation that maybe all of life is a game of looking around you, assessing where you're situated in your environment, who are your neighbors, how to avoid getting blown up or otherwise perishing. And I thought it would be really interesting to try to extend this to music, make like a Conway's Game of Life pattern sequencer, or like a drum machine that could either generate music, or I was thinking just for a visualizer or an interesting input interface. That's kind of on the idea on the table for future plans for this thing. So I needed to learn how to use the web audio API, and luckily there's a lot of really good prior art from Dave Yarwood and Chris Ford, who made these libraries for using the web audio API that are really amazing, but they actually didn't help me quite so much because they were too smart. It would have been something great if I wanted to just use it as my audio engine, but I wanted to actually learn how to use the web audio API Enclosure myself. And so it was actually Sonic CLJS by Bruce Howman that really helped me get my head around it, because it's totally dumb. It doesn't do anything special at all. It's just uses JavaScript interop. And so I ended up with something like this, which is the same. I realized that everything is a grid, and by making that I could toggle the notes on and off with the piano roll grid, and I put this staff here with the Mario, just, well, honestly, because it seems like all of the CSS animation tutorials use Mario for teaching sprite animation, because Mario was, one of the first sprites. And this kind of something started stirring up subconsciously, and I remembered this game that I used to play on the Super Nintendo back in the early 90s, which was really, that might have been why I became a musician. It was because I played this game, which was so easy to just throw a bunch of notes on the screen, and it sounded amazing. And I had this experience that we probably understand as programmers. When something comes to life, it does something, and I was literally bouncing off the walls in ecstasy. I made this thing. Oh my God, that's amazing. And one problem with it, though, is that it uses an internal format that, how do I save my composition? You couldn't just get a MIDI file out of it or anything. So this is a screenshot of the original game, and there's a paper that was written that explains all of the different remakes of the game that have been made over the years. And I found out that it's actually the subject of a university course. The University of California at Berkeley has, they teach a music theory course using this game. And so I thought I would give it a try. Here's where I gave it a bass clef. And my idea was that I would use actual music notes. Here's, I added a percussion staff, which is used for representing a drum set. And this was one of my early attempts at SVG animation. So that's was the first Mario that I tried to make myself, and it looks really bad because I was using Inkscape to do a bitmap, to trace the bitmap and convert it to SVG, and then just putting the SVG in line in my code because that was the only way that I knew how to display images. And so the way I solved that was I actually made a thing. I found, hold on, I found this thing, pixels to SVG, which you upload an image and it puts it on, it makes an HTML canvas element, and then uses that to extract the pixel data, just pixel for pixel. It doesn't try to do anything fancy, because we're only talking about 8 and 16-bit graphics. And so I made a Clojurescript version of it here that does this. You can upload a file, and then it gives you the SVG here. So then my graphics looked a little bit better, but this is a blooper, which I realized that when I finally got everything working, it would actually be kind of boring, because then everything would work. But the weird things like this, where I was trying to make Mario jump over the notes and he hangs himself and actually turns blue. And yeah, here was an idea that I was fiddling around with, was a circle of fifths color wheel, and that would go on this key signature robot. And the idea is that you would turn the wheel, and it would adjust the key signature, and it would tell you, like no sharps and flats is C major or A minor, and then as you would turn it clockwise, it would add sharps, I believe. I can't remember which is which. And that's the undo dog, which I used. The whole app was made in Reframe, which is really great, because I could use Reframe undo, and also Reframe undo redo, because a lot of people had complained that the original game didn't have a redo button, and you want to be able to undo your undos. And so I decided to hold auditions for who got to be the redo button. And so I thought maybe redo rabbit on the lower right, but it turns out it's actually a frog. But I thought that I thought it, I guess those are his eyes, but I thought they were ears. And then there was that's the undo dog on the top left, and then to the right I thought would be redo wombat, and then in the corner is the redo robot, and I had two different versions of redo orangutan. But it was a really stressful day of auditions that people left in tears, and I decided to just go with the frog thing, because it was already part of the game. And pixel art is kind of harder than you would think. So this was when I finally gave in and decided that creating my own sheet music rendering engine was a little bit more complicated than would be practical. Music rendering is actually a really hard problem, and it has to look just right, or if something even looks slightly weird, it will throw people off. And the logic of the stems and the beams is so complicated. And the Mario Paint interface really, by using the note heads, I realized that actually it was no longer necessary to have multiple staves, because you can put different parts on the same staff and recognize them by the picture. And so then this was, I had a little video here of the first time that I actually got it working. And I don't know, how's everybody doing?
Yeah, this is fascinating. There's no new questions, but keep going.
I rehearsed this earlier and realized that I was afraid that I was not going to have enough. And so I thought I was going to have to stretch it out and it would look like I didn't have anything. And then I just rehearsed it today and realized that that it was actually way too much. But what I think might be cool would be to actually explore the code a little bit, since this is a Clojure meetup. Let's see, that's in. Yeah, here we go. Oh yeah, so this is. I'm really proud of my castle. The castle I made myself out of bricks and mortar, and all it is actually dashed lines with different offsets, and so it's a functional castle. Here's the line for the mortar row, which are the little black lines between the bricks. And there's the brick row and the columns, and then it all composes to make the castle that we see. And it uses, these are functions that I literally stole from Bruce Howman's code. Nobody even really knows about that one. It's called Sonic CLJS, which, I actually feel bad that I haven't mentioned Overtone, which was created by Sam Aaron for live coding. And Sam went on to create Sonic Pi, which runs on the Raspberry Pi. And so I imagine this was something that Bruce, who, if you don't know, is the author of Figwheel and Dev Cards and probably other things that everybody uses. But I imagine that this was an attempt to take a lot from Sonic Pi and do it in the browser with the web audio API. So it uses core async to just load these samples and decode them and turn it into a web audio buffer source. And here's my functions for it just changes the sample rate of the sample. It plays it back at different speeds to create the different pitches, which so I also wired this up to the keyboard so that it can be used as a live instrument. And it's really fun when you use the cat. I was babysitting a little girl who had autism and was kind of unruly, and so I took out my laptop, and she had so much fun with this that it was worth making just for that hour. It was also some valuable battle testing for the app, as well as my laptop. She was banging on it. So, yeah, does anyone have any questions?
I don't see any new questions yet, but I'm really enjoying this. This is really cool. I guess I have a question. What are some ways in which people can contribute to this, or like what features do you intend to add from here, or is it mostly done?
No, I don't think this could ever be done. And actually, I have more ideas for it than I think I would ever be able to get to. But let me get to the repo here. Let's see. I created some issues. One actually is this, was to be able to import music XML. So I created an XML, and because that music XML is actually, it's a format for music markup, but it's also I think the most popular format that music programs use to talk to each other. And yeah, it's missing the ability to load and save songs, but that is actually should be pretty easy. These issues are actually minor things.
Yeah, very cool. So we did have a few questions come in. One is, what's the biggest learning aha moment that you've had?
Wow. Let's see. The whole thing was kind of one. Well, yeah, there's so many things I could talk about there. I had a couple of big ideas in the slides that I actually just scrolled past them because it was actually kind of a joke, and I got it from Mark Engelberg, who did a few really great talks where he would distill them down to big ideas, and so I thought I would take that, but it's kind of it's funny because these are not so big ideas. The first one was, it's all a bunch of loops. And Rich Hickey's talk, Design, Composition, and Performance, actually was a huge inspiration for this. And right down to the title, I decided to go with an acronym, MECCA, to describe the different processes involved in making things. And it turns out that was what Rich did in his talk. The funny thing was I had not I hadn't seen the talk at the time that I started working on this. I had only heard of Clojure a little bit. But he said that music did all of this before we had computers. Was an interesting line, and realizing that then the second idea was everything is a grid. And actually, yeah, one thing I wanted to show was the grid, because sometimes the grid is visible and sometimes it's not. And so what I wanted to do was so here is this is just my view namespace that has all of the visual elements. There's the note guides, the note targets is what it was. And so if I change the visibility property here to visible, and then that's recompiling. And so now we can see how it works. There's no, I didn't use any, there's nothing that's tracking the mouse cursor, which is, I think would be, the normal way that somebody would make something like this. And I found a JavaScript version that I referred to, but this actually works entirely differently. They're just, these are just, it's an invisible grid, and each one has a mouse over property that. So it's kind of all of the graphics are self-aware, which I think was kind of an interesting, and that was a big revelation. I think that by doing it all in SVG, it could possibly open up more opportunities for having interactive elements, and we could have different characters reacting to the music, or I don't even know, but yeah, the biggest aha moment, that Conway's Game of Life drum machine idea. If somebody wanted to help me figure out how to do that, especially with John Conway's passing, it would be a really interesting tribute, I think, to have a Game of Life interface. I don't know, has anyone heard of anything like that?
I've not heard of anything like that, no.
But yeah, I think that would be pretty fun. And, it would be, like some kind of pattern sequencer. And it would be a generated music seems to be all the rage these days. I haven't gotten really excited about it, to be honest. I'm interested in human-made music.
Awesome. Looks like Daniel had another question for you. I'm going to let him jump back into the stream so he can ask it.
All right.
Hi. So I first wanted to tell you, so there's a thing I actually happened to hear about. I was listening to a user interface podcast where they talked about this husband-wife couple. They live on a boat and they do sort of any type of software project they can think up. They just make it. I don't know. They're creatives, right? So they've got this thing called Orca. And if you look it up, their name is 100 Rabbits. That's like the name they produce software under. And if you look it up, they've got a thing called Orca, and it's sort of like it's like a music machine by grid, so to speak. Like each, I haven't really dived into it because it's a little bit like intimidating when you look at the interface of it. But I think it's along the lines of what you would be interested in. So. To ask my question, so this is on a different vein. So like I wanted to know, like, does this represent in your mind, a way for kids to get their hands dirty exploring music creation? And what thoughts do you have about that?
Yeah, that's but also for big kids. It the beauty of it being an open source project is that it could very easily have hidden features that could be opened up. These don't have to be the Mario Paint samples. I can load whatever samples we want, and it could quickly become something that, well, I'm a little bit weird, but something that I would use to try making something besides Mario Paint music with.
Yeah, I think for my part, I can say you've kind of inspired me on something I was stuck on. I've got the idea to make an app that helps a person to design a quilt block for quilters. Sometimes a lack of computer tools sends them back to traditional drawing on paper and everything. Like I think there's an opportunity there. So when you talked about the grid that your system uses, I think that it kind of informed an approach that I'm going to take for that. If you don't mind, I'm probably going to run with that. So I wanted to thank you for that. And it's not in the vein of music, but I think you've got some really cool ideas here. And it was interesting. I think my favorite thing that I learned tonight was when you talked about what Rich Hickey said about how music was doing all this before computers existed. Like music had loops, and music had these mathematical relationships, and music. I'm not sure what other things he meant in the context of his statement, but it just got me kind of thinking about that. So, to see the ideas that are in Clojure brought back to the space of music and to see it applied harmoniously there is pretty cool. It feels like a match that's correct somehow. So I applaud what you're doing, and I think it's really fun.
Oh, well, thanks a lot.
All right, so we've got about 5 minutes left. I don't know if you've got any last closing remarks. Otherwise, we'll start to wrap up.
Oh, yeah, I don't know. I think I've reached the point where I say that's all I've got.
Excellent. All right. Well, thanks a lot. I'm going to pass it over to Daniel, and he'll wrap us up.
Yeah, I'd just like to say, Bobby, thank you for preparing the talk and everything. I really feel I feel really grateful for people like you who are willing to put in the effort just on a simple request from me to to present just for the love of it, to come and share what's been clearly a journey of passion. And so thank you for your time and investment. So to wrap up, this has been a meeting of the Clojure Mid-Cities Meetup. Our speaker, Bobby Towers, music and Clojure practitioner. Thank you, Bobby. And if you guys want to join us in the future, great ways to stay connected are to join us on Slack. That's at the Mid-Cities Meetup Clojurian Slack channel. So to be more clear, you join the Clojurian Slack workspace, and then you join the Mid-Cities Meetup channel. And then another way is to, since you came here through Meetup, just join the group on Meetup. And then you'll see the notifications of all our upcoming items. Thanks to everyone who asked questions and who tossed their thoughts in the comments. It really added a lot to the meeting. And if you guys have ideas for what you want to present in the future, even if it's just a 5-minute idea, or if it's a 30-minute idea, or if it's an hour-long idea, I hope you'll feel free to reach out, share those thoughts to John or to myself or to Mike Nygaard. And then we'll coordinate the process of getting your bio and your abstract all listed under Meetup so that we can get it advertised and then people can come and hear what you have to say. So thanks for everyone's participation and interest, and I really just am grateful for the group. I think on a personal note, it's quite a gift to my sanity to be able to have a monthly meetup where we can talk about Clojure. I know sometimes the podcast world grows weary for me. Like I listen to all the guys talking about all the guys and girls talking about Clojure and Elixir as well, but the face-to-face of it and the live interaction of it just really kind of adds something that I think in times of COVID and pandemic means more than ever. So thanks to everyone for coming out and sharing your thoughts and your information. And Bobby, I really do think if you look up that Orca thing, like I say, like I'm not a user of it. It intimidated me the first time I looked at it, but it's like music by grid, and I think you may take some inspiration from it if you go try it out. So thanks to everyone, and we'll just say farewell till next time. May all your parentheses be matched, and thanks.